In a single question we have studied all the formulae. So we will take one a little bit analytical question, right? You can read what if you don't understand something, just rewind the video and read it again, okay? And if you still have problems, if you still have doubt, we can take the doubts in the next question, I mean the next video. You can write the comments so that we can take up the doubt of previous lecture in the next video, okay? So we are taking a little bit, we are increasing the level of difficulty slight. So a mixture of 50 ml of hydrogen and 50 ml of oxygen, volume are same, is allowed to effuse. Now this is the mixture, okay? In the mixture 50 ml hydrogen is stored and 50 ml of oxygen is allowed to effuse through an effusometer till the residual gas occupy 90 ml. The total gas left is 90 ml. It means some 10 ml is leaked, isn't it? 10 ml gas has been effused or leaked. What is the composition of effused gas? The gas which is left, what was the composition, and what is the composition of residual gas? So the total volume was 100 ml and residual volume is 90 ml. So the gas effused out equal to 10 ml. So let us say out of 10 ml, the volume of hydrogen effused is equal to x ml and volume of oxygen effused equal to 10 minus x ml. So this is obviously V1 and this is V2, isn't it? And this is happening at the same time. So V1 by V2 equal to D2 by D1. So obviously oxygen is 32, 16 plus 16. The molar weight of oxygen is 32 and molar weight of hydrogen is, because how do we write it? V1 by V2 equal to M2 by M1, and then we will write a square root. So obviously what happened? 32 by 2 square root equal to 4, isn't it? So x is obviously 8, isn't it? 8 upon obviously 2, which is 4. So x is the volume of hydrogen. So 8 volume or 8 ml of hydrogen is effused and hydrogen was 50 ml. Look into the question, it was 50 ml. That means if hydrogen was 50 ml, that means how much is left? 42 ml. And obviously oxygen was, now if hydrogen is 8 ml, hydrogen effused is 8 ml, total volume effused was 10 ml. So what do we say? 2 ml of oxygen is effused. So oxygen, residual oxygen in the container or in the cylinder will be 50 minus 2, that is 48 ml. Right, you understood this question? Now we are taking question number 3. Again, don't look the solution. Try to control your senses, try to control your eyesight. Don't look the solution. Never you should look the solution. That is a dangerous, one of the dangerous thing while preparing for any of the competitive exams, right? So we are taking up the question. Let us say now the question is, there is a tube. This tube has two open ends, Y end from which ammonia is introduced in the tube. There is one X end from which HCl, both are gases, HCl gas and ammonia gas are being introduced. So at some point P inside the tube, a white dot appears, white fumes appears, white dot or white fumes appear at some point P inside the tube. Calculate the distance of P from X or from the HCl end. Now let us say the point P is somewhere here. Now we are going into the solution. Let us say this is point P and point P is some D1 distance. So because the length, total length is 200 centimeter, which is given in the question. So from ammonia end, the distance of P is obviously 200 minus D1, right? So first of all, from the figure we have understood that how much is the distance of P from HCl, that is D1, and how much is the distance of P from ammonia end, that is y, that is obviously 200 minus d1, because the total distance or the length of the tube is 200 centimeter. Now because there are two gases and they are diffusing at different rates, so R1 upon R2 is obviously M2 by M1 square root. So let us say rate of ammonia upon rate of what is here HCl equal to, obviously ammonia is 17 molar weight and HCl is 36.5 plus 1, sorry 35.5 plus 1 equal to 36.5 square root. That comes out to be 1.465 is to 1. Okay, and we have studied already that R1 upon R2 equal to D1 upon D2. Even if we don't study it, even if we have not studied the formula, we still understand that rate is speed and speed is distance upon time taken. So time taken is common because P is the point at the same time at which the gases molecules are striking each other, they are reacting, and white dots or white fumes are appearing. So obviously R1 by R2 equal to D1 by D2. Now R1 by R2 equal to 36.5 upon 17 square root, that is 1.465 upon 1 equal to D1, and D2 is 200 minus D1. We can easily solve, or we can write it in the inverse way, that is D1 upon D1 plus D2 equal to R1 upon R1 plus R2. There are two methods. Either you can solve from here directly, we have got our answer, right? Even if we are not solving from here, let us say we are not solving from here, then what is the formula? We have easily understood what is the formula, and the formula is R1 upon R2 equal to D1 upon D2, or we can write, we are adding plus 1 both sides, so plus 1 will make them D1 upon D1 plus D2, R1 upon R1 plus R2. Either you can use this one. This is simple mathematical manipulation. Basically we are using this one and we are done with the question. So we can simplify D1 and we can get the answer, or you can write this one. So, or you can just inverse it, that is D1 plus D2 upon D1, because we have told what we have studied D1 upon D2. We are simply taking inverse of it, right? What we are doing, we are taking inverse of it. So what we can do is we can use it like this, or we can use D1 upon D2 upon D1 multiplied by R1 plus R2 equal to R1, or equal to D1, right? Like this, you can do like this, upon right here D1 plus D2, simply do it like this, that is D1 plus D2 upon D1 equal to R1 plus R2 upon R1. This implies D1 equal to D1 plus D2 multiplied by R1 upon R1 plus R2. Either you do it like this, it's your choice, or you simply solve R1 by R2 equal to D1 plus D2. Well, in my opinion, I won't do like this, because now I have to do more analytics and that is time consuming. So what I will do, I will simply do it like this only, this one. So with this, I hope you understood. Please rewind the whole video, try to understand, and then you can solve from this topic. The topic was Graham's law of diffusion. The name of the topic is already written over here, Graham's law of diffusion and diffusion. We are taking it up, and when we are taking it up, you can simply reread it, whole topic, and now you can solve any of the question, any previous year question, any level of difficulty, you will be able to solve that question. Thank you. Thanks a lot.